Alright, these are notes on covalent Lewis dot structures. In class we used geometric shapes to show the sharing of electrons between atoms and understanding that a line between two atoms is going to carry 2 electrons being shared between those. We then went on to learn about the full valence shared method. Remember, these are only for covalent bonds because covalent bonds share electrons. So this is for covalent Lewis dot structures only. In covalent Lewis dot structures, we start by calculating the number of full valence electrons, or how many electrons are on the outer shell. This is always 8 per atom we're discussing, unless it's hydrogen and helium, who only have 2 valence electrons on their shell. We then need to find the valence electrons, or the number of actual valence electrons the atom has. So you look at the periodic table based on the family. Nitrogen's going to have 5 valence electrons, but it wants 8 full valence electrons. For shared electrons, this is how many electrons I need to put in a bond. We're going to take full and subtract it from the valence number we calculate. To figure out how many lines or bonds I need in my image, I'm going to take the shared electrons and divide by 2. Remember that a single line or a bond is holding 2 valence electrons in covalent Lewis dot structures. The last part of our image is going to be the dots, or the lone electrons. And all we're going to do for that is take the valence number minus the shared electron number. So we'll look at an example on your notes handout on the back. Nitrogen trichloride. We follow 3 steps. The first thing we always want to do is decide if it's ionic or covalent. Because nitrogen and chlorine are both nonmetals, this is going to be a covalent structure. The formula for that is going to be nitrogen. There's only one of them. And then chlorine, tri means 3, so we get that subscript 3 there. Step 2, I need to calculate this S, V, and F method. I like to write my atoms individually at the top of my calculation, so I know what atom I'm talking about. I have 3 chlorine that I need to calculate for, so I'm going to stick that as a coefficient here, telling me to multiply anything I get for chlorine by 3. So we're going to go with F first, the full or max number of valence electrons. Nitrogen's going to want 8 to be happy. I'm going to add that to the 8 that chlorine also wants to be happy, but remember I have 3 chlorine, so 3 times 8. That's going to give me a total of 32 electrons. Go down to valence. These are the number of actual valence electrons it has. So I look on the periodic table, and for nitrogen I'm going to get 5. I'm going to add that to how many valence electrons chlorine has. It's in the halogen group, so it's going to have 7. Once again, you have 3 chlorine there, so we need to multiply this by 3 as well. 21 plus 5 is going to give me 26. You should always get an even number for your actual number of valence electrons, otherwise this won't work out. Need to calculate the shared number, or the number of electrons I'm going to put in bonds next. Remember, we do that by taking the full minus the valence. Okay, so this time I've got the 2 numbers I want to work with. I'm going to take 32 and subtract from 26. This is the number that all the atoms will be happy with. This is the number of electrons I actually have to work with. So when I subtract those 2 numbers, I'm going to get 6. That's how many electrons need to be shared between nitrogen and 3 chlorine. In a picture, we're going to show that through lines or bonds. So for B, this is going to equal S divided by 2, or the number of electrons I need to share divided by 2. Remember, bonds equal lines in our picture. So if I take S, which was 6, I divide it by 2, I'm going to get 3 lines, or 3 bonds. The last part of a picture are the lone electrons, or the dots. I'm going to find that from valence minus shared electrons. So I'm going to take the 26 electrons I have to work with. I'm going to take out the 6 that I put in my lines, or my bonds, and that's going to tell me how many electrons I have left over to play with. It's going to be 20 electrons in this case, and those are going to be the dots in my image. Out of all this math, the pieces of information we're most interested in are the 3 lines and 20 dots, and what atoms I'm working with. Okay. Step 3, I actually want to draw this Lewis dot structure. The least electronegative atom goes in the middle. So if we look at a periodic table, remember that the most electronegative, element is fluorine up here. So as we get farther away from fluorine, we get lower electronegativity. So nitrogen is farther from fluorine than chlorine, so it's going to go in the middle. I have 3 chlorine. I'm going to stick them as far away from each other around the nitrogen as I can. Remember, we don't want to stick them in a straight line. Okay. I have 3 lines here I need to place in my image. Remember, we're connecting atoms just like we connected the shapes in class. So 1 line between nitrogen and each chlorine. Step 4, we always want to check the octet rule. Remember, oct means 8. So I'm looking for my rule of 8. If there is 2 electrons in a line, right now nitrogen has 2, 4, 6. I need to give him 2 more dots to have 8. Then I'm going to move out to my chlorines. This chlorine only has 2, so I need to add 6 dots to it. The remaining 2 chlorine are the exact same. To double check myself, I should have only drawn 20 dots on this image. Each chlorine is going to get 6 dots. 6 times 3 is 18 dots on my chlorine, plus the 2 on nitrogen is 20 dots. Just want to double check that chlorine follows the octet rule. I have 2 in the bond, 4, 6, and 8. So all my atoms are happy with octet. I've checked that off.